Machine learning. Those words probably conjure up a lot of images in your head, from the Terminator to self-driving cars to an anthropomorphized chatbot you're almost certainly familiar with. However, let's put away all the smoke and mirrors for a second and talk about what that term really means. According to Wikipedia, machine learning is a field of computer science that deals with the development and study of statistical algorithms that can learn from data and generalize to unseen data, and thus perform tasks without explicit programming language instructions. All that means is that we can create algorithms that take in a lot of data, process it using statistics, and now when that algorithm receives new data, it can use similarities or differences to the data it already has to do something. It could be sorting B's from threes, red lights from green lights, deciding what new video to put in front of you during your third hour of doom scrolling. That's right. I see you. But it's also being used in more beneficial ways like evacuation planning for disasters. For the purposes of creating music, we're going to be talking about a program called AudioStellar that takes samples and uses machine learning to categorize them into different clusters based on their similarity to each other. I looked into the different types of machine learning because I wanted to know what algorithm AudioStellar was using, and I got in way too deep. So now, I'm going to curse you with some of that knowledge as well. I majored in the arts to get away from math! AudioStellar classifies different sound samples by their timbric similarity, which is a measurement of several aspects of a sound, including quality, color, and texture, specifically without pitch. It turns those values into numbers that place each sample on a 2D grid, so a sample library can be represented as clusters of points on a graph. But how does the machine know to sort all these points into different clusters? Good question, you handsome son of a gun. That leads us into a specific type of machine learning that's aptly named clustering. There are several different algorithms that can be used to identify clusters of data, and they all have their own advantages and drawbacks. Some examples include centroid-based clustering, which groups points based on their proximity to certain fixed points called centroids. There's also connectivity-based clustering, which either groups all points into one big cluster or assigns each point as its own cluster, and then separates or merges the points into multiple clusters, respectively. There's also density-based clustering, which is what I believe AudioStellar uses. Now, I couldn't find any information from the creators, but I'm pretty sure AudioStellar uses a form of density-based clustering called optics clustering. It uses an algorithm that keeps track of each point's furthest and closest points and puts them in linear order based on how reachable they are to other points. Then it gives each point a radius that determines if a point next to it is part of the same cluster. It's got some advantages like being good at clustering noisy data with different densities, creating variable amounts of clusters, and handling clusters of different sizes, which makes it ideal for a program like AudioStellar that needs to sometimes differentiate between sounds that might be very similar but should belong to different clusters. That's not where AudioStellar's features end, however. The software allows you to create different units that interact with the points in different ways, such as a particle unit that lets you create particles that spread out and trigger different samples. There are also sequence units that let you connect different points and play them in sequence. For my composition, I use several sequence units in tandem with a point unit to get some interesting rhythms happening. I think it's really cool that depending on how far 2 points are in the sequence, they play on different beats, which leads to some interesting natural shaping of the groove. Anyways, enjoy.